Hello friends, are you frustrated with mathematics, especially when it comes to find the inverse of matrices by using elementary operations? Definitely, because it's very tedious work and it requires lots of energy and focus with the precise calculations. So you don't have to worry. Today I am here with you to help you how you can find the inverse of matrix of any order by using elementary operations. So till class 12 standard, we are asked to find the matrices of the order of 2 by 2. We have to find the inverse of matrices of the order 2 by 2, but today I'm going to show you how you can find the inverse of matrices of order 4 by 4. So if you know how to do this, then of the order 3 by 3 will be very easy. So today what we are going to do is, you can see the equations here. So this is the applications of matrix. So if we want to find the unknown value of this w, x, y, z or z, so you can find with the help of matrix. Like I've written down the same value in the matrix. So I'm going to uh, I'm going to find the inverse of this matrix. Okay, A inverse. So for that purpose, what I have to do is, we know that A inverse A will give me identity matrix. If we take the product of any matrix and there its inverse will give it will give identity matrix. This is one rule, and another is, if I multiply any matrix with uh, their identity matrix, it will give me the same value. Like in the number system, if I multiply any numbers with 1, it will give me the same number. So my job here is to transform this A into identity, so that I'll get here A inverse A. That means if I transform this by anyhow by using the operations, there are two operations like row operations or the column operations. Any one we can use, but not simultaneously, one at a time. Means if I want to use row operations, I have to use only row operations till I get the answer. So by using that operation, we can transform this A matrix into identity matrix, and automatically by that rule, this I will transform to A inverse. So for that, let me write in this form: A matrix 2 1 0 2 0 1 3. Okay, this is the identity matrix of order 4 by 4. So my job here is to transform this matrix into this, so that I will get here inverse of matrix A, because whenever we multiply with whenever we take the product of any inverse of matrix, and that matrix will get the identity matrix. So first what we'll do is, this is not a trick, but it's a concept. I believe in concept, not a trick. So we have to make this to be 1, because I am transforming this matrix into this identity matrix. So this has to be 1, and other these elements should be 0. This should be 1, this should be 1, this way. So my focus will be this, and making this other 0. We'll go like this. Well, I'm applying the rows operations, so I have to take care of this element, so that whenever I apply, if I find 1 here, so if there is 0, so whatever the operations I am working with, that won't disturb my value, which I already got it. So I don't want to disturb my value which I wanted to get. Okay, so let me do first. What we'll do is, let's change r1 and do the swap, right? R3, that means take all this row to this row 3 to row 1. Let's write it down: 3 1 0 2. Other will remain same. Okay, again this row will go here, right? I'm interchanging, it's kind of swap. 2 1 0 2. So r4 will remain same. Here what you have to, whichever the operations you are applying in the left hand side, you have to apply in the right hand side. So r3 will go there. Okay, so your next approach will be, why I swap it, why I interchange, because I want to get it 1. So now I can apply the operations, that is r1 is transforming to r1 minus r3. Okay, this is 3. So when I transform, 3 minus 2 will give me 1. So now apply 3 minus 2 1 1 minus 1, 0, 0 minus 0, 0, 2 minus 2, 0. Other will remain undisturbed. Again r1 plus r1 minus, I am applying this operation. Okay, r1 minus r3, row 1 minus row 3, 0 minus 1 minus 1, 0 minus 0, 0, 1 minus 0, 1, 0 minus 0, 0. Other will remain unchanged. Okay, so here what we got is, we got 1, our first objective, our first mission, we can say, right? So now next mission is to make this 0, already 0, and now we move to the this place. What we can do, I can take the difference of these two rows, right? That means r3 can be in written as interchange to r3 minus r4. Okay, i am I am applying only one operations at a time. We can apply more than one as well. So I'm applying in r3, so other will remain same. Just copy it as it is. 2 minus 2, 0, 1 minus 2, minus 1, 0 minus 3, minus 3, 2 minus 2, 0. Okay, this side also we have to use the same operation. Okay, again r3 minus r4, 1, 0 minus 0, 0, 0 minus 0, 0, 0 minus 1, minus 1. Yeah, let's move to the next. Our next mission is to make this 0. How we can make r4? This is r4, r4 minus 2 r1, right? So that I will get 0. Now here what you have to do is to avoid the mistakes while doing calculations. We often do the mistakes while doing calculations, so it is always safe to write like do this, follow this, just multiply r1 with 2, 2 1s are 2, 2 0 0. In the same way multiply with 2. Okay, so it is better to write with the pencil, this one, so that later on you can erase it. I'm applying in the r4, other will same, just copy it as it is without getting distracted or making mistakes. So r4, 2 minus 2, 0. This was our mission is done. Okay, so 2 minus 0, 2, 3 minus 0, 3, 2 minus 0, 2. Same here, I'm applying operations on r4, so other will remain same, unaffected, right? So now r4, 0 minus 2, that will give 2, because minus minus plus, 0 minus 0, 0, 0 minus 2, minus 2, 1 minus 0, 1. Now our next mission is here, this one will go like this, maybe like this. Okay, so that we won't disturb whatever we have already accomplished. We don't want to change this, our mission, right? We already got this, so this element should not be disturbed. So what I will do is to make this part 0. What I'll do is, this is r3 will undergo r3 plus r2. That means if I add this, I will get 0, 1 0 0 0, r3, right? Other will blindly you can write it, r3 plus r2, 0 plus 0, 0, minus 1 plus 1, 0, minus 3 plus 1, minus 2, 0 plus 1, 1. So this is 2. You have to apply the same operations on r3. Now r3, 1 plus 0 1, 0 plus 1 1, 0 plus 0 0, minus 1 plus 0, minus 1. Okay, here's go. Now we got it, right? The next move will be, we have to make this element to be 0, and comes to this part, we'll make this 1 and 0 1 like this. Try to make this as 1 1 1 1 0 0 0, so that half of the identity matrix will be done, then next half will do after that. So this is tedious work, but anyway, by practice we can learn it. So I will do it right here. Now what we'll do is, our mission is to make this 0. So let's say r4 is changing to r4, that is 2 minus 2 r2. Okay, so once again, whenever this kind of whenever this kind of things comes, now you multiply this here, r2 with 2, 2 0 are 0, 2 1 are 2, 2 1 are 2, 2 1 are 2. Same here, 0 2 1 are 2, 2 0 are 0 0. So it will become much easier, plus there will be no mistake. 1 0 0 0 0 1 0 0 minus 2 1. So I am applying only in the row 4, that is r4, 0 minus 0 0, 2 minus 2 0. That was our mission, which is accomplished. 3 minus 2 1, 2 minus 2 0. And same here, 1 1 0 minus 1. Now 2 minus 0 2, 0 minus 2 minus 2, minus 2 minus 0 minus 2, 1 minus 0 1. Okay, so next step is let's make it 1. So just do a swap or interchange. r3 will undergo interchange with r4, that means 1 will remain same, r1 will remain same, 0 1 1 1. Let's interchange. 0 0 1 0, 0 0 minus 2 1. Same here, 2 minus 2 minus 2 1, this will go there, 1 1 0 minus 1. Okay, so here comes what we have to do now is we have to make this part 0. So for that, what we'll do is, let's r4 plus 2 r3. Again you multiply this one with 2, other will be 0. So again this 2 to the 4 minus 4 minus 4, 2 1 the 2. So 1 0 0 0 0 1 1 1 0 0 1 0. Now r4, so 0 plus 0 0, 0 plus 0 0. So minus 2 plus 2 0 1 plus 0 1, minus 1 0 1 0 0 1 0 0 2 minus 2 minus 2 1. Now r4, 1 and r3, right? 1 minus 4, 1 plus 4 5, 1 minus 4 minus 3, 0 minus 4 minus 4, minus 1 plus 2 1. Okay, so we are almost done. Only 2 steps is required, that is we have to make this 0 0. r2 will undergo interchange, that is r2 minus r3, that gives me 0, which I want. 1 minus 1 0, 1 minus 0 1. Here comes our identity. Still 1 is there, not so early. This is a tedious job, but anyway, this really improves our calculations. Okay, I'm so sorry, I'm applying r2, that means r2 minus r3, 0 minus 2 minus 2, 1 minus minus 2, this will give me 3, 0 minus minus 2, that will give me 2. So 0 minus 1, this will give me minus 1. So other will remain same. Okay, that's my bad handwriting. Anyway, now we'll make this 0, our final mission. R2 minus R4, 1 0 0 0 0 minus 0 0 0 1 minus 0 1 0 0 0 1 minus 1 0. Now this is the final move, and we'll get the inverse. So I have minus 2 minus 2 minus 5 minus 7 3 minus minus 3, that becomes plus 6, 2 minus minus 4, that becomes plus, that is 6, minus 1 minus 1 minus 2, 2 minus 2 minus 2 1, 5 minus 3 minus 4 1. Yeah, so this becomes I when this becomes I when any matrix multiply with their inverse. That means you can see here, so this becomes I, right? So this becomes I only when any matrix multiply with their inverse. So from here, comparing these equations, we get this to be A inverse. So let me write it down. A inverse, okay, minus 1 0 1 0 minus 7 6 6 minus 2 2 minus 2 minus 2 1, 5 minus 3 minus 4 1. So this is what we needed. So this is the inverse of A. So if we find A inverse, then I will show you first. Yes, you can see this value, which is unknown, w x y z. From here we can exactly able to find the value of these all variables. How? We already got A inverse. That means, let me write, okay, let me write this. This is A matrix. Okay, that means A get multiply with w x y z. Okay, that whole matrix, I'm writing it on the A, will equals to this 8 7 6 10, 8 7 6 10. Okay, let me say this is x, this is y. Okay, so A into x equals to y. So let's multiply both side by A inverse. That means A inverse A will give me identity matrix, right? Just before we prove, and into x will give me A inverse y. So any matrix, if we multiply with identity matrix of that matrix, that gives us x, which we discuss in which we already discussed about this. Now A inverse y. So we found out the result, that is this x is nothing but the value of, let me show you, this x is nothing but the value of w x y and g. This value will be given by A inverse, that is minus 1 0 1 0 minus 7 6 6 minus 2 2 minus 2 minus 2 1, 5 minus 3 minus 4 1, into y is 8 7 6 10. This is the applications of matrix. So when we multiply this matrix, this two matrix, will get the value of w x y g. And very important thing is, our goal is not only to get the value of w x y z, but the thing is, whichever the values we change it here, 8 7 6 10, that is the equations, this one, whatever the value you change, you can easily get the value of w x y z. You don't have to solve always, just put the value of here. If you want to change 3 4 5 6, they will give the value of this one. So this is the basis for which computer works. So inside the computer, in the software, so whenever you give the output, this will give, whenever you use the data like xyz, any equations like this, you will get the value directly here. So that's all. So in the next video, I'm going to show you how you can get the value of wxyz by multiplying these two. Simply multiplying these two will get this one. Okay, bye, thank you.